Our topic is linked list, so what is linked list? What are its type? Above diagram shows that simple structure of linked list. Linked list is a linear data structure. It is a collection of nodes. Each node contains two parts, i.e., data part as well as link, address part. The linked list is a very flexible dynamic data structure. A linked list is sequence of data structure, which are connected together via links. Linked list is a sequence of links which contains items. Each link contains a connection to another link. A linked list is a set of dynamically allocated nodes, arranged in such a way that each node contains one value and one pointer. Linked list is the second most used data structure, after array. So let's see structure of linked blocks. Above picture shows that the structure of linked blocks. These are the explanation of each elements. Let's see the representation of linked list. Woo! A linked list is represented by a pointer to the first node of the linked list. The first node is called the head. If the linked list is empty, then the value of the head is null. Each node in a list consists of at least two parts. A data, b, address of next node. Below is example of linked list with integer data. Let us create a simple linked list with 3 nodes. We should follow simple 3 steps. Start with the empty list. Link first node to the second node. Link second node to the third node. So let's see types of linked list. Singly linked list. Doubly linked list. Circular linked list. Let's study the singly linked list implementation. So let's study singly linked list. Linked list is a collection of similar elements. Each element points to the next element. Linked list is a linear list of specially designed nodes, where each node divided into 2 parts. This is the structure of linked block. Info field. It contains necessary information about the items of the list to be stored and processed. Next field. It contains address of the next node. This field is used to access the next data item in other. This is example of singly linked list. Representation of linked list. First, static or sequential or array representation. The linked list will be represented by 2 parallel arrays of same sizes. One array for the actual data item is called info field of the node and the other array for the address called the next field of the nodes. 2. Dynamic or pointers or linked representation. The size of the linked list may increase or decrease according to the requirement of applications. A dynamic representation of linked list do not have limitation and use space proportional to the actual number of elements of the list. Features. It wants ultimate size of the linked list to declare in advance. Array implementation of the linked list is very simple and efficient in random access of the elements. Operation on singly linked list. 1. Traversing. 2. Insertion. 3. Deletion. Traversing a linked list. This operation is used to visit each one of the list exactly once in order to access the info stored in nodes. Let's see algorithm first. If start equals null a, print, list is empty, b, exit and if. Second, set ptr equals start third, repeat steps 4 and 5 until ptr equals null fourth, access and apply ptr info. Fifth, set ptr equals ptr next and repeat sixth, exit. Insertion at specified position in linked list. In order to insert an element after the specified number of nodes into the linked list, we need to skip the desired number of elements in the list to move the pointer at the position after which the node will be inserted. To insert a given data at a specified position, the below steps is to be followed. Traverse the linked list up to position 1 nodes. Once all the position 1 nodes are traversed, allocate memory and the given data to the new node. Point the next pointer of the new node to the next of current node. Point the next pointer of current node to the new node. Let's see algorithm. 1. If ptr equals null right overflow, go to step 12 end of if 2, set new underscore node equals ptr3, new underscore node right pointing arrow data equals 4 Vatican liras, set temp equals head 5. Set I equals 06, repeat step 5 and 6 until I7, temp equals temp right pointing arrow next 8, if temp equals null right, desired node not present, go to step 12 end of loop 9, ptr right pointing arrow next equals temp right pointing arrow next 10, temp right pointing arrow next equals ptr 11, set ptr equals new underscore node step 12, exit. Deletion at specified position in linked list. In order to delete the node, which is present after the specified node, we need to skip the desired number of nodes to reach the node after which the node will be deleted. We need to keep track of the two nodes. The one which is to be deleted, the other one if the node which is present before that node. For this purpose, 2 pointers are used. Let's see algorithm. 1. If start equals null 2, print, overflow, 3, return 4, end if 5, set ptr equals start 6, assign value equals start info 7, set start equals start next, second node becomes the first node. 8. Release the node pointed by ptr to the memory heap. 9. Exit.